So let's get started with our lecture on confidence intervals for proportions. You'll use this when your data is categorical. Okay. Um, so our general form of a confidence interval, as we've seen before, is our point estimate plus or minus our margin of error. Okay. So our point estimate is the sample proportion. And that estimates the true population proportion. Okay, so we're constructing a confidence interval for the population proportion using the sample proportion. Now, our margin of error, this differs from what it was last time. We're not going to use a t-distribution. Instead, we're going to use a standard normal or z-distribution. And that is your standard error or your margin of error for your confidence interval. So the formula I want you to take away from today's lecture is that our estimate for our point estimate is p hat. That's just our observed total with the characteristic divided by our total number of observations, plus or minus this quantity. So this quantity comes from the z-distribution with alpha over 2 in the left or right tail. And we're going to multiply by this, square root of p times 1 minus p over n. And p hat here represents the sample proportion. That's how we construct a confidence interval. So let's get started with an example. Okay. So just to reiterate, this is telling us our sample proportion, or p hat, is t divided by n, where t is the number of observations with the characteristic out of the sample of size n. And you can use this confidence interval whenever n times p hat times 1 minus p hat is bigger than 10. You can still use it when it's less, but it's not the recommendation. Okay. And there would be drawbacks. Okay, so as we've seen before, our margin of error is this quantity. Okay, and if we wanted to have a specified margin of error, depending on which scenario we're in, we can estimate the sample size required for a specific margin of error with this formula. And you can calculate it with this formula if you have an estimate of the sample proportion available. If you have not collected any data where there's no estimate or guess on p hat, then you have a less accurate way of calculating the sample size required for a specific margin of error. And you'd have to do this formula. It'd be 0.25 times z of alpha over 2 divided by your margin of error squared. Okay. So let's go ahead and do an example. We have a company, it produces parts, and it wants to estimate the proportion of defective parts produced. So they collect a random sample of 150 parts, and it's found that the sample proportion is 12%. Okay, and based on this information, we're going to calculate a 90% confidence interval for the proportion of defective parts. So first, we're going to check that we don't have to worry about using this method. So we're just going to check that n times p hat times 1 minus p hat is bigger than 10. And when we do that, we get about 15.84, so we're good. We can go ahead and proceed. We don't have to worry. The other thing is we want a 90% confidence interval, so alpha is going to be 10%. 1 minus alpha needs to be 90%, so alpha is 10%, and alpha over 2 is 5%. So you can calculate this from the standard normal table, or you can use an online calculator. Okay. And if I use an online calculator, I'm going to go to the inverse normal distribution here, and I want 0.05 because it's a 90% confidence interval. So alpha is 10%, and alpha over 2 goes in each tail, so it's 0.05. Mean 0, standard deviation 1, and let's calculate that. That gives us this number, 1.645. and this was in the online stats book calculator section. Okay, so we go back, that's the 1.645. We remember this formula for calculating confidence intervals. This formula is over here, so we just write that down. We're going to plug in our given information. Okay, so our p hat is 12%, 0.12 plus or minus this 1.645 times the square root of 0.12 times 1 minus 0.12 over 150. And this gives us a confidence interval that says that the population proportion of defective, if it's contained in this interval, could be as low as 7.6% or as high as 16.3%. Okay. So you can see that there's a margin of error, and it's, rather sizable. The company might like a better estimate of the proportion of defectives. So what if they wanted it to be within 2%? Okay, and here we need to convert 2% into 0.02. How many parts should be sampled? How many observations would be required, or what sample size? Well, we want our margin of error to be 2%, so we convert it to 0.02. It has to be in decimal form. Then if we had a prior estimate, if we had 12% available, we're going to use this formula. And we go ahead and do that, right? And we plug in the given information here, and it tells us we need to sample 715 parts. Okay, so that's a lot of parts being dedicated to the sample. So like I said, it will be time consuming and costly to have a small margin of error. Okay, now if no prior estimate of probability, if the 12% wasn't provided and you just had to know how many parts to sample, you'd proceed. Okay, and you'd proceed using this formula if you did not know that an estimate for the proportion was 12%. Okay, so let's go back to that. You just plug in the given information. The z of alpha over 2 is 1.645. We use the calculator for that. Our margin of error is 0.02. We go ahead and do this calculation. It says we need to sample 1,692 parts. That's quite expensive. And we have to proceed with this calculation. This would be a less accurate estimate of how many parts we need to sample, because we did not have our prior estimate available. Okay. So here's another example, and it says here a drug is being developed to determine how likely side effects to the drug are. Okay. And it collects some data, so it has a random sample of 400 individuals. The participants are classified as experienced side effects or not. The sample proportion of individuals experiencing side effects is 3%. And we want to construct a 99% confidence interval for the proportion of individuals experiencing side effects. Okay, so the first thing to do is just to write down all the information that's given in this problem and the formula for the confidence interval. Okay. One thing that I just remark is side effects could be anything from a headache to, death on the extreme side. Okay. So we just write down our formula for a confidence interval. Our p hat was given to us. That's 3%, 0.03. We have a sample size n of 400, so we're going to plug that in. So we have the 0.03, we have the 400, and this whole formula inside the square root is counted for. What you might be wondering is, where did this number come from? That came from the standard normal distribution, from this thing. And alpha, we want a 99% confidence interval, so 1 minus alpha has to be equal to 99%. Alpha has to be 1%, and alpha over 2, therefore is 0.5% or 0.005. We're going to use that same online calculator to determine what z of alpha over 2 is. Okay, so let's go to it. I want not 0.05, but I want 0.5%. So I'm going to add a decimal, keep the mean and standard deviation the same. So z means mean 0, standard deviation 1. And we recalculate it to be this 2.576. That's the same number we used here, 2.575. So slightly off, I used a different calculator. If you use 2.575 versus 2.576, it's okay. Okay. So we go ahead and we perform this calculation for the formula of the confidence interval, and we get that it could be as low as 0.6% to 5% as the proportion of individuals experiencing side effects for this drug. So the company, as well as the FDA, they need to determine if this is an acceptable rate of individuals that will experience side effects. It should also depend on how extreme the side effects are or what they are. Okay, so you can see that there's quite a large margin of error. It goes from about a little over 0.5%, 0.6%, to 5.4% basically as the possible proportion of individuals that experience side effects. So what if we wanted to have a more accurate answer? Well, we could increase our sample size. And if we didn't have anyone in our study and we didn't know what the proportion would be, and we wanted our margin of error to be accurate to within 1%, 0.01, then we go ahead and we plug this in. And I want to emphasize here, we don't have an estimate for the proportion. Okay, we multiply by 0.25, we take that 2.575 and we put it here. Our margin of error should be 0.1%, so 0.01. So I apologize there. And we go ahead and we calculate this, and we're going to get we're going to need over 16,000 individuals in this study. 16 and a half, over 16 and a half. That's not very practical for the company. And in addition, the company typically has to pay or offer some incentives for individuals to be in the study. So this is going to be very, very costly if they want to have an accurate estimate of 1%. Okay. Now, if they did have a prior estimate of 3%, then they could sample less people, okay? And the sample size required would be given by this formula. If they had an estimate for the proportion of individuals that experience side effects, and they'd see that they need to sample or have 1,931 individuals in this study. That is also quite expensive and time consuming to track all these individuals, to pay all these individuals or compensate them. And it can be quite prohibitive and difficult because individuals are allowed, due to ethical issues, to drop out of a study at any time. Okay. But in theory, we would need 1,931 individuals in this study. Okay. Well, that was my lecture on confidence intervals. Thank you very much.